Hello everyone, and welcome to Group 502's live presentation for MAE 106. My name is Spencer, and I'm joined by my fellow presenters, GT and Roy. As the propulsion engineer, I chose to implement a one-way bearing mechanism using a rack and gear assembly to link the rear driving wheels to the pneumatic piston. When the piston fires outward, as seen in Figure 1, the rear axle and wheels rotate and push the car forward. Once the piston retracts, the one-way bearing at the axle allows gear motion to continue without spinning the drive wheels backward, as seen in Figure 2. In this animation, you can see how the actuation of the piston causes the drive wheels to rotate. Due to limitations in SOLIDWORKS, the functionality of a one-way bearing was difficult to replicate, which is why the return stroke of the piston rotates the wheels backwards.
Thank you, Spencer. Hi, my name is Gurpreet, or GT for short, and now we'll be talking about the steering part of the project. For the steering, we decided it was best to do the bell crank steering as it felt like one of the most fundamental steerings of the three. One of the key deciding factors that it was to help decide the steering was it was acronym steering friendly, which means that when a robot turns, for the wheels not to slip, they need to be having different radiuses. Furthermore, one of the challenges of the steering was the servo placement, and we concluded by simply having it in the front with the support of the robot. Moreover, the long supports on each side of the body will help with the front and back side of the robot to be connected. Next slide, please. Here's a short animation of the steering to help demonstrate and show the clearance of the linkages and as the wheel as well, along with the placement of the servo for the steering entirely. Now I'll pass it on for Roy for the chassis.
Thank you, GT. My name is Roy Yang. I'm the chassis engineer. As you can see from Figure 1, there is a 13-inch tire on top of the chassis as an air tank. The height of the chassis from the ground to the center of the tire is 16 inches. The diameter of chassis is 12 inches. As you can see in Figure 2, we have the electronic components on the center plate of the chassis, including the battery pack, MOSFET, air control valve, 3D compass, and Arduino Uno. In Figure 3, that's the magnetic switch and the magnet that's attached to the rear wheel. In Figure 4, it shows the access hole on the top of the chassis to allow a hose to go through it and connect air tank to the air control valve. And on the next slide, that's the final assembly of our robotic car. Thank you for watching. I hope you enjoyed the presentation.